At 11:56 on the morning of January 27, 1902, a wooden shed on Park Avenue in Manhattan held 200 pounds of dynamite. 30 seconds later, every window in the Murray Hill Hotel was gone. A steam hoist had been hurled through a brick wall. 2 bodies lay in the street, blown out of a trench 40 feet below the sidewalk. The contractor who stored that dynamite was Major Ira Shaler, son of a Medal of Honor general, a man the newspapers had already nicknamed the Hoodoo Contractor. 5 months after the explosion, Shaler walked up to a rock face his chief engineer called Rotten. He tapped it with his cane. The rock came down on top of him. He died 4 days later. Shaler was one of 15 subcontractors hired to build something that had never been attempted: 21 miles of railroad under the most crowded city in America in less than 5 years. This is the full story of the machines that built the New York City subway. In this documentary, we are going to cover 5 chapters. First, the forgotten subway that came 30 years before the real one. Second, the $35 million contract that launched the largest urban excavation project in American history. Third, the tools and machines that actually did the digging and why the answer surprised us. Fourth, the tunneling shields that carried the subway under the East River. And fifth, how the equipment evolved across 40 years and 3 construction eras, including one famous story about a Caterpillar bulldozer that we spent weeks trying to verify. This is one of the most overlooked construction stories in American history, and the details are unlike anything we have covered on this channel before. But before any of that, we need to go back to 1870, because the New York City subway did not start with the IRT contract in 1900. It started with a man named Alfred Ely Beach, an editor, an inventor, and a man who built a secret subway under Broadway without telling anyone in city government. Beach held patents on pneumatic tube systems for mail delivery. That was his cover story. In 1869, he rented the basement of Devlin's clothing store at the corner of Broadway and Warren Street and began digging. He told the city he was building a small pneumatic mail tube. What he was actually building was a passenger railroad. His workers excavated 300 feet of tunnel in 58 nights, working only after dark to avoid detection. The dirt was hauled out in bags and dumped into wagons on the street. The tunnel was 8 feet in diameter, lined with brick, and fitted with a single track. A 48-ton blower built by the Roots Company of Connersville, Indiana, which Beach nicknamed the Western Tornado, pushed a cylindrical rail car through the tube on a cushion of compressed air. When the car reached the far end, the blower reversed and sucked it back. The system produced no steam, no smoke, and needed no horses. Beach opened his pneumatic subway to the public in February 1870, 25 cents a ride. The waiting room had a chandelier. A fountain played near the entrance. A grand piano sat against the wall. New Yorkers loved it. Over 400,000 visitors rode the system in its first year. The technology worked, but Beach had a problem that no amount of engineering could solve. His name was William McGeer Tweed. Boss Tweed controlled Tammany Hall, which controlled every transit franchise in New York. Tweed had his own plans for an elevated railroad, and he was not going to let Beach undercut him with a tunnel. The state legislature passed Beach's transit bill twice. Governor John Hoffman, a Tweed ally, vetoed it twice. Beach ran out of money. By 1873, the financial panic of that year killed any remaining hope of private investment. The tunnel was sealed. The Roots blower went silent. And for 42 years, Beach's subway sat underneath Broadway, forgotten by the city that needed it most. Beach died in January 1896. He never saw his tunnel reopen. For the next 4 years, New York's population continued to explode. By 1900, 2 million people were packed onto the island of Manhattan, making it the most densely populated place on Earth. The elevated railways along 2nd, 3rd, 6th, and 9th Avenues were running at capacity. Horse-drawn streetcars jammed the streets below. The average commuting speed across Manhattan was less than 6 miles per hour. The city was suffocating on its own congestion, and the answer that Beach had built 30 years earlier was still sitting underneath Broadway, sealed behind a brick wall. But in 1912, workers excavating the new BMT Broadway line broke through that wall and found the tunnel. The tunnel was intact. The rail car was still there, sitting on its track. The roots blower was still there. And so was the piano. Beach's hydraulic shield, the iron ring he used to push through the earth while workers removed soil from the front and bolted iron segments behind it, was the direct ancestor of every tunneling shield that would follow. That design would cross under the East River, under the Harlem River, and under the Hudson. Beach never knew it. If you are enjoying this documentary, please take a moment to like and subscribe. It helps us keep making these deep dives into construction history. 30 years after Beach sealed his tunnel, the city was choking on its own traffic. Horse-drawn streetcars, elevated railways, and 2 million residents were packed onto the island of Manhattan. The Rapid Transit Commission had been trying to get a subway built since 1894, but no contractor would bid on it. The project was too big, the engineering too uncertain, and the financial risk too extreme. Finally, in January 1900, a contractor named John B. MacDonald stepped forward. MacDonald was born in County Cork, Ireland, in 1844. He had come to America as a child, fought in the Civil War, and built his reputation on tunnel work. He had completed the Howard Street Tunnel in Baltimore, which is still in active freight use today. He had built bridges in Montreal and a railroad tunnel in Hamilton, Ontario. He looked at the New York subway route and told the commission he could build 21 miles of subway from City Hall to the Bronx in 4.5 years for $35 million. But MacDonald could not post the required $7 million surety bond on his own. Enter August Belmont Jr. Belmont's father had been the Rothschild banking agent in America. The younger Belmont saw the subway as a generational business opportunity. He organized a financial syndicate that covered the bond, with 4 surety companies posting $250,000 each. In exchange, Belmont would operate the finished subway for 50 years through his newly formed Interborough Rapid Transit Company. After 50 years, ownership would revert to the city. The contract was signed. The most important construction project in New York City, history had a builder, a banker, and a deadline. The chief engineer was William Barclay Parsons, a Columbia-educated civil engineer who had spent years studying transit systems in Europe. Parsons toured the subways of London, Liverpool, Glasgow, and Paris before designing the New York system. In London, he saw the deep tube approach, with tunnels bored far below the surface and passengers ferried down by slow hydraulic elevators. Parsons rejected that model. New York's geology gave him an alternative. Manhattan is a slab of hard gneiss and mica schist covered by a relatively thin layer of earth and fill. Parsons chose the cut and cover method. Dig a trench from the surface down to tunnel depth, 30 to 50 feet below the street. Build the tunnel structure in the open trench, cover it back up, and restore the street. The advantage was speed. The disadvantage was chaos. Every block of Manhattan above the trench had to keep functioning while the ground beneath it was torn apart. Gas mains, water mains, sewer lines, electrical conduits, pneumatic mail tubes, and steam pipes all had to be relocated or suspended from temporary I-beams by chain hangers before any digging could begin. On some blocks, the utility relocation work took longer than the actual tunnel excavation beneath it. Workers had to identify, trace, and reroute every pipe and cable without interrupting service to the buildings above. A single mistake with a gas main could cause an explosion. A single broken water main could flood the trench. Street traffic had to cross the trench on timber decking strong enough to hold loaded horse carts and streetcars. Pedestrians walked over the construction on temporary wooden sidewalks, while men blasted rock 40 feet below their shoes. And all of this happened in a city that never stopped moving, 24 hours a day, 7 days a week. McDonald subdivided the contract into 15 sections and assigned each one to a different subcontractor. Companies like McMullen, Snare, and Trieste handled the deep rock cuts on Lexington Avenue. L.B. McCabe took sections in Harlem. E.P. Roberts and the firm of Terry and Tench handled lighter ground. Ira Shaler took Section 6. On March 24, 1900, Mayor Robert Van Wyck drove a silver Tiffany spade into the ground at City Hall Park. The crowd cheered. The newspapers ran drawings of the finished subway. But the man who actually started building it was not the mayor. 2 days later, a subcontractor named James Pilkington swung a pickaxe into a sewer line at the corner of Elm and Green Streets. That pickaxe, not the mayor's silver spade, was the true start of the New York City subway. The silver spade is now in the Museum of the City of New York, accession number MNY 71907. The pickaxe is lost to history. Now we come to the part of this story that surprised us more than anything else in our research. The construction of the Empire State Building required guy derricks and concrete hoists operating at a pace that has never been matched. The cableways at Hoover Dam swung 20-ton concrete buckets across Black Canyon every 78 seconds. 102 Bucyrus steam shovels carved the Panama Canal through 9 miles of volcanic rock. Every great American construction project of the early 20th century has a signature machine at its center. The New York City subway does not. The chief engineer's own progress report, published in Engineering News in 19002 and now archived at nycsubway.org, states it plainly. Very little use was made of mechanical apparatus of any kind on the subway excavation. Most of the excavated material was shoveled by hand. That sentence deserves a moment. The most famous transit system in the world, carrying 5 million riders every single day, was dug out of Manhattan bedrock by men with hand tools. The reason was geometry. A steam shovel in 1900 was a massive rail-mounted machine. A Bucyrus or a Marion weighed tens of tons, sat on temporary track, and needed a wide-open face to swing its dipper arm. These machines had carved the Panama Canal through jungle and volcanic basalt. But inside a timber-decked trench under Broadway, with gas lines suspended from chains overhead and horse-drawn streetcars running on temporary decking 6 feet above the workers' heads, there was no room for them. The streets were too narrow. The utilities were too dense. The working space was too tight. The machine that actually did the work was the Ingersoll Rand BCR pneumatic rock drill. It weighed about 15 pounds. It was handheld. It ran on compressed air piped down from stationary compressors on the surface. Simon Ingersoll had founded his drill company on the island of Manhattan in 1871, the same year Beach sealed his tunnel 1 mile to the south. Ingersoll's percussion drills had cut through the Mont Cenis Tunnel in the Alps and the Gotthard Tunnel in Switzerland. His company merged with the Sargent Drill Company to form Ingersoll Sargent, and then in 1905 merged again with Rand Drill to become Ingersoll Rand. Now 30 years after Simon Ingersoll built his first drill, those same machines were cutting through the bedrock directly underneath the city where they had been invented. The drilling and blasting procedure on the IRT was brutal in its simplicity. Crews worked 2 overlapping shifts. The drilling shift ran from roughly 6 in the morning to 11 at night. The mucking shift ran from 8 at night to 1 in the morning, overlapping with the drillers for 3 hours. An operator would position the BCR against the rock face and bore a 7-foot hole into the schist. Then he would move and drill another. A typical blast pattern required dozens of holes drilled across a face that could be 25 to 35 feet high and 40 to 50 feet wide on the Lexington Avenue sections. When every hole was loaded with dynamite and the pattern was set, the blast went off. The concussion rattled windows for blocks. Residents living along the route grew accustomed to the sound of underground explosions at all hours. After each blast, the mucking crews moved in. And here is where the mules enter the story. Blasted rock was shoveled by hand into 3/4 yard and 1 yard dump buckets mounted on small rail cars, running on 24-inch gauge track laid directly on the tunnel floor. Mules hauled the loaded cars through the darkness to the nearest shaft. These were real mules, living and working underground for weeks at a time, stabled in improvised underground pens near the shafts. At the shaft, a stationary hoisting engine powered by steam lifted the loaded buckets to the surface using a derrick. On the deeper Lexington Avenue sections, where the rock face dropped 35 feet and the trench ran 50 feet below the street, larger 1.5 to 2 yard containers called battleship skips replaced the smaller buckets. These ran on 3-foot gauge track and coasted downhill to the shaft under their own weight, then were hauled back up by cable wound on steam-powered drums. At 121st Street and Lexington Avenue, a custom-built gantry hoist handled the transfer of loaded skips from the underground track to the surface. It was not a crane in any modern sense. It was an improvised system of chains, cables, and steam-powered winches bolted together on site by the subcontractor to solve a problem no catalog machine could handle. The excavated rock went somewhere remarkable. Barges carried the spoil down the East River to various dump sites around the harbor. Some of it ended up at Governor's Island. Some went to Rikers Island. But the single largest recipient was Ellis Island. In 1900, the island measured 3 1/3 acres. By the time the subway fill operations were complete, Ellis Island measured 27.5 acres. The gateway through which 12 million immigrants entered the United States was built, in large part, from the rock underneath the subway their descendants would ride every day. Chief Engineer Parsons' reports are staggering by any measure. The original IRT contract excavated 3.5 million cubic yards of earth and rock. That is enough material to fill a column 1 yard square stretching from New York to Los Angeles and back. 71,000 tons of structural steel came from Carnegie Steel. 10,000 tons of cast iron went into columns and supports. 500,000 cubic yards of concrete required 1.5 million barrels of cement from the United Building Materials Company. Nearly 1 million square yards of waterproofing membrane sealed the tunnel against groundwater. And through all of this, 1.5 to 2 tons of dynamite were consumed every single day. Chief Engineer Parsons confirmed that figure himself in 1903. Over 4.5 years of active construction, the total runs into the low thousands of tons of high explosives detonated underneath a city of 2 million people. The wonder is not that accidents happened. The wonder is that more did not. If you are finding this documentary informative, we would appreciate it if you could like and subscribe to help us continue making these in-depth construction history videos. But accidents did happen, and the worst of them brought us back to the man whose story opened this documentary. Major Ira Alexander Shaler held Section 6, running from 34th Street to 42nd Street, directly under Park Avenue. This was the deepest rock cut on the entire IRT route. Shaler's father was Brigadier General Alexander Shaler, who had earned the Medal of Honor at the Battle of Maurice Heights during the Civil War. The younger Shaler was an experienced contractor with a growing reputation for bad luck. His section had already suffered minor incidents. The newspapers had begun calling him the Hoodoo Contractor months before the explosion. On the morning of January 27, 1902, Shaler's crews had stored reserve dynamite in a wooden shed at the surface of the Park Avenue shaft. Storing dynamite near the working face was standard practice. Constant blasting meant that residents and police along the route had grown accustomed to the sound of underground explosions throughout the day. At 11:56 in the morning, 2 smaller detonations preceded the main blast. Then 200 pounds of stored dynamite ignited at once. The explosion killed 5 people at the shed and in the immediate vicinity. A steam engine used for hoisting rock from the trench was picked up bodily and thrown through a brick wall into the tunnel of the Park Avenue streetcar line. Debris showered down on the Murray Hill Hotel and the Grand Union Hotel. Every window facing the blast was shattered across a full city block. 2 workers were blown out of the trench and onto the street above. Over 125 people were injured. In 1905, a court found the city government jointly liable, ruling that the Rapid Transit Commission had failed to establish adequate safety protocols for explosive storage on subway construction sites. 5 months later, on June 17, 1902, Shaler was inspecting his section with Chief Engineer Parsons. They reached a rock outcrop at the tunnel face. Parsons examined it and called it rotten, meaning geologically unstable. Shaler disagreed. He stepped out from under a protective timber cover and tapped the rock face with his cane. The entire outcrop collapsed on top of him. He was pulled from the rubble alive, but badly crushed. He died on June 29, 1902. He was 40 years old. The man the newspapers called the Hoodoo Contractor was killed by the rock he refused to respect. The total confirmed death toll on the original IRT Contract 1 is at least 16 killed and 125 injured. But that figure covers only the 3 largest named incidents. The actual number of workers killed across all 15 sections over 4.5 years of construction is almost certainly higher. Records from that era are incomplete, and many of the laborers were recent immigrants whose deaths went unrecorded in official city documents. The men who survived carried granite dust in their lungs for the rest of their lives. Silicosis, the scarring disease caused by inhaling fine rock particles, was not even formally named until decades after the subway was finished. But the men who drilled the holes and mucked the rock knew what was happening to them. They coughed, they lost weight, they kept drilling. We have covered how the subway was dug. Now we need to talk about how it crossed the rivers, because cut and cover only worked on land. The moment the subway route needed to cross from Manhattan to Brooklyn, or from Manhattan to Queens, an entirely different technology was required. That technology was the tunneling shield. The concept went back to Mark Brunel, who patented a rectangular tunneling shield in 1818 for the Thames Tunnel in London. His son, Isambard Kingdom Brunel, completed that tunnel in 1843 after 18 years of construction and multiple floods that killed workers. In 1869, a South African-born engineer named James Henry Greathead improved the design dramatically by making the shield circular instead of rectangular. He used it to build the Tower subway beneath the Thames in just 10 months. That circular geometry became the worldwide standard for soft-ground tunneling. Beach had used a similar circular shield for his 1870 pneumatic subway under Broadway. Now, in the early 1900s, the Greathead pattern shield was the only machine capable of carrying the subway under New York's rivers. The Steinway Tunnel, connecting Manhattan to Queens at 42nd Street, was one of the first major applications. Groundbreaking was June 3, 1892, under contractor Pomeroy P. Dickinson, with William Barclay Parsons serving as consulting engineer. The twin tubes were 15 feet 6 inches in internal diameter, 8,500 feet long, and reached 88 feet below mean high water. The shield itself was a massive iron cylinder with a sharpened cutting edge at the front and a battery of hydraulic rams at the rear. The rams pushed the shield forward into the saturated silt and clay of the riverbed, a few inches at a time. Workers inside the pressurized chamber at the front of the shield excavated soil by hand from the face, while engineers maintained compressed air pressure at roughly 40 pounds per square inch to hold back the river water. Behind the shield, crews bolted cast iron ring segments into place to form the permanent tunnel lining. Each ring was assembled from curved sections, caulked with lead, and grouted to seal against leaks. The Joralemon Street Tunnel, connecting Manhattan to Brooklyn, used the same method. Its twin tubes reached 91 to 95 feet below mean high water. It was the first underwater subway tunnel between the two boroughs, and at the time of its completion, it was one of the deepest subaqueous tunnels in the world. But compressed air tunneling was lethal in ways that went beyond the obvious risk of the river breaking through. At 40 pounds per square inch, nitrogen dissolved into the blood of every man working in the heading. When they returned to normal atmospheric pressure at the end of their shift, that nitrogen came out of solution as gas bubbles in the joints, the spine, and the brain. The workers called it the bends. The formal medical term was caisson disease. The Brooklyn Bridge caissons had introduced the condition to the American construction vocabulary decades earlier, when Washington Roebling himself was permanently crippled by it. But subway tunneling made caisson disease routine. Roughly 50 Sandhogs died of the bends during the Pennsylvania Railroad's North River tunnels between 1904 and 1908. Death certificates were initially falsified to conceal the true cause. And then there were the blowouts. When the compressed air inside the shield found a weak point in the riverbed above, it punched through the silt and erupted from the surface of the river in a geyser of mud and water. Everything inside the heading, tools, timber, men, was sucked toward the breach. In February 1916, a leak in the compressed air seal of the shield on the Montague Street Tunnel sucked 3 Sandhogs through an 18-inch hole in the tunnel face, through 12 feet of river mud, and out the surface of the East River on top of a 25-foot geyser. Marshall Mabee survived the ejection and was pulled from the water by a passing tugboat. Frank Driver and Michael McCarthy were not as fortunate. Both died. The earlier Hudson Tunnel blowout of July 21, 1880, had killed 20 of 28 men trapped in the heading. Sandhog mortality on the early Hudson tubes was reckoned at roughly 1 man per foot of tunnel advanced. The compressed air workers, who by now were formally called Sandhogs across every job site in the city, organized themselves into the Compressed Air Workers Union in 1892. Local 147 in New York remains active today, still sending men underground to extend and repair the same tunnel network that their predecessors began building more than a century ago. If you are finding value in this documentary, a like and subscribe helps the channel reach more people who care about construction history. Now we come to the final chapter of this documentary: the evolution of subway construction equipment across 3 distinct eras. The IRT was built between 1900 and 1904, almost entirely with hand tools. Ingersoll ran pneumatic drills, dynamite, mules, derricks, and the improvised engineering of 15 subcontractors working under a $35 million deadline. Opening day was October 27, 1904. 150,000 New Yorkers rode the subway in its first 5 hours of operation. The fare was 5 cents. The dual contracts era began in 1913, when the city signed agreements with both the IRT and the Brooklyn Rapid Transit Company to expand the system by 618 miles of new track. For the first time, steam shovels appeared in meaningful numbers on subway construction. But they only worked on the open-cut sections in Brooklyn and the Bronx, where the streets were wider and the underground utility networks less dense. The 4th Avenue line in Brooklyn, the Sea Beach line, and the West End line all used Bucyrus and Marion rail-mounted steam shovels to excavate the wider, shallower trenches through less congested outer borough terrain. Manhattan remained hand tool territory throughout the dual contracts era. The IND era, beginning in the late 1920s, brought the first real mechanization to Manhattan subway work. The independent subway system was the first system designed, built, and operated entirely by the city government, without private companies running the finished lines. The 6th Avenue line, which broke ground when Mayor Fiorello LaGuardia drove a ceremonial pickaxe into the pavement at Bryant Park on March 23, 1936, was arguably the most difficult tunnel job in New York City. Subway history. The route had to thread between the active PATH tubes of the Hudson and Manhattan Railroad, running directly under 6th Avenue, the Catskill Aqueduct carrying 500 million gallons of water per day, roughly 200 feet below the surface, and the still operating IR to 6th Avenue elevated railroad directly above. Blasting was restricted to tiny charges, mostly detonated at night, to avoid disturbing the PATH service. 3 named contractors carved up the Midtown section of the route. Rosoff Broder Construction took 40th to 47th Street and 33rd to 40th Street. The Carlton Company handled 27th to 33rd Street. The George A. Flynn Corporation built 47th to 53rd Street under a contract valued at $4,616,476. A central compressor plant and shaft were built at 46th Street. The line cost $59.5 million for 2.5 miles and was completed on December 15, 1940. There is a famous story about this section of the subway that we need to address honestly. The story says that a Caterpillar bulldozer was lowered in pieces through a 12-foot shaft beneath 6th Avenue in 1936, reassembled underground by Sandhogs working under Edison bulbs, and remained sealed beneath the street for 11 years. We spent weeks trying to verify this story. We searched the Caterpillar corporate archives in Peoria, Illinois. We searched the Historical Construction Equipment Association records. We went through the complete nycsubway.org line histories for the IND 6th Avenue line. We checked every accessible New York Times archive reference. We found no contemporary newspaper account, no engineering progress report, no Caterpillar service record, and no official transit authority document that confirms the story. There is also a technical problem. Caterpillar did not manufacture its own bulldozer blade until 1945. That date comes directly from Caterpillar's official corporate timeline. Any Caterpillar tractor working underground in 1936 would not have been a Caterpillar bulldozer. It would have been a Caterpillar crawler tractor fitted with a cable-operated blade manufactured by a third party, likely Latourneau, La Plante Choate, or Bucyrus Erie. The distinction matters because it changes the identity of the machine at the center of the legend. That does not mean the story is entirely false. Crawler tractors almost certainly did work underground during IND construction. The 46th Street shaft and compressor plant are documented. The scale of the excavation required mechanical assistance. But the specific details of the legend, the 11 years underground, the machine sealed in and forgotten, have no primary source behind them. We would rather tell you that honestly than build a documentary on a fact we cannot verify. What we can verify is extraordinary enough without embellishment. 3.5 million cubic yards of Manhattan rock and earth, excavated in 4.5 years. 71,000 tons of structural steel from Carnegie. 500,000 cubic yards of concrete. 1.5 million barrels of cement. A workforce that peaked at 7,700 men, earning $2 a day, breathing granite dust that scarred their lungs permanently, if the dynamite and the falling rock and the compressed air did not kill them first. At least 16 confirmed dead and 125 injured on the original IRT contract alone, with the true total across 40 years and 3 construction eras almost certainly many times higher. The rock they pulled from underneath Manhattan built Ellis Island. The holes they drilled still carry trains. Today, 5 million people ride the New York City subway every day. Most of them pass through tunnels framed by steel and concrete that was poured between 1900 and 1940. The tunnel linings in the oldest IRT sections, the ones that were hand-drilled and hand-mucked and hand-concreted by men earning $2 a day in 1902, are in better structural condition today than many of the extensions built after 1970. A retired subway worker with 38 years underground confirmed exactly that in a public comment on another documentary about this project. He said the original tunnels are still in far better shape than the modern ones. The men who built them are gone. And the rock they drilled through is still holding. And 5 million people trust it with their lives every single day. If you enjoyed this documentary, please like and subscribe to Construction Legends. Every week, we cover heavy equipment history, construction disasters, and the machines that built the world.